from the definition we have the input, it is so this is the input, and you're using the definition of this form. Okay, so notice here, do you remember last times I introduced the windows? So for example, this is the signals of xn, and now you just want the component from k1 to k2. So how do you represent this one? This one is actually just times by u k1 minus u k2 plus 1. So notice here it is plus 1. Okay, so it means you just want the signals in this domain from k1 to k2. All right. So now, from this one, you find this part. It is actually it just want the signals from 0 to 7, right? Because for this part it's from k1 to k2. So here it is k2 plus 1. And this corresponding to this part, so it means you just want the signals from 0 to 7, right? Okay, so now we can change this bound. It should be from 0 to 7, and then this part is equal to 1, and then you can calculate. So remember, for the continuous signals, if you want the signals in k1 to k2, actually this is input. It is xt times by u k1 minus u k2. But for discrete times, it is k1 minus u k2 plus 1. So this is different. All right. The last question. So according to the definition, so first step, we can change the order of these two summations. In this case, we can firstly calculate the J transform of this part, because the original signals is the summation of many components, right? But if we can change the order of these two summations, we just calculate the J transform of each component and then together. Because each component is very easy to calculate. All right. So for this one, we know this part, this function, it can transform to so this one means when n is equal to 5k, this part is equal to z minus 5k. When it's not equal to this one, this is equal to 0, right? This component, it has value only when n is equal to 5k. In other places, it's equal to 0. So now, from this domain, we only has one value, 5k. Okay, so this part, the middle part, is just equal to J minus 5K. And then you have your summation from the out. So you can get solution easily. So remember, so we frequently use the property of xn times by minus k. So this one is equal to sk delta minus k. Right? And also for this one, if you want to summation from a total domain, summation from the whole domain, because it only has one value, right? When n is equal to k. So this is equal to sk. So this is the property, this important property. You will use it again and again. Any problem about these three questions?
Because you only have one value, so you can change the summation.
Yeah, because here you analyze, you only have value in the where n is equal to k.
To the second step, you change the order of the summation.
Yeah.
Because of it only has one value.
Yeah, because this part, this part is firstly you calculate this one total signals, and then using the Jesus form.
Yeah.
And by this way, we can firstly calculate each component, Jesus form of each component, and then summation together.
But if you change the order of summation, you have to prove that the later part will have a limit. It is infinite.
Yeah. But for this
finite,
question,
sorry.
but for this question,
So you don't
we
need
can
to prove
change
it,
it.
you can just change it.
Yeah. All right. So problem one, it is you calculate the Jesus form from using two methods. One is represent the xn and the combination of impulse signals, and the other one is combination of the step signals. So the first one is very easy. So you just write down each impulse and the impulse functions, and then calculate the Jesus form. So this is easy. It has this component, and for each component, you can easily calculate its Jesus form, and then add them together. This is easy. The second one. Okay, so for these signals, we want to represent it by the step functions. So we can see two components. One is this part, and the other one is this part. Okay, so for this part, we can firstly express the signals by of these signals, and then we just keep window just from 0 to 4, and then we have this part. Similarly, for this part, we first write down the expression of this function, and then just write down from 5 to 7, right? So we can decompose by two signals and then add them together. So the first signal is U, because we want from 0 to 4, so it should be times by UN. minus 4 plus 1. And second part, it is the original square is this one. And then we want the signals from 5 to 8. Okay, so we see here, this 5, this line. So you can express again. Okay, so now this one is so this one is easy to calculate. You can use in the property of differential I just introduced. Right? So this one, this is actually is not these two are different. So you can express by minus 5 and then plus 5. So in this way, you can calculate easily. So this one is similar. So this one is similar, is minus 9 and plus 9. And this two is easy to calculate. Okay. So from this problem, you need to know in the for discrete signals, you can express by the combination of impulse signals and also the step functions, right? So it has some important properties. And for these two basic signals, you can find the J-search form very easily. And also you need to know, for this kind of signal, you need how to express it by the delay step signals. First you minus something and plus something. So this is all right. So the second topic is how to find the inverse J-search form. Before the tutorial I've introduced, first you can, so it has 3 standard steps. One is divide the J-search form by J, and then expressed by something forms of AK over J minus BK plus CK J minus K, this kind of form. And then second step is times by J. And by this way, you can express by AK J over J minus BK. And this y is CK J minus plus 1. Right? So now we have these two basic forms. This form is corresponding to the step function, exponential functions. And this one is corresponding to the impulse functions. So these are 3 standard steps. Okay, so the first question. First step, divide by J. So it is equal to J minus 4 over J and for this one, we can express by the multiplication of two equations. And then this one can further express by two equation summation together. It is 2 over J minus 2 minus 1 J minus 3. So here you need to know how to calculate these two constants. For example, now you first express by AK, A and B. So you want to find these two constants. So A is equal to X. This part times by, because now you want to find the constants over this part is minus 2, Z minus 2 here. So you need firstly times by Z minus 2. So in this way, actually you cancel this part, right? And then you just let Z is equal to 2. So it's 2 over 4, 2 over 3. Because if you don't times by these things, here when Z is equal to 2, this one is equal to 0, but this is not defined. So it's easy to remember here. First times by something, and then this part is equal to 0. In this case, you can divide it. Okay, so here it is equal to 2n minus 1. And then second step, you just times by this part times by Z. So this one is equal to Z and Z here. Okay, so Z over Z minus 2 and Z over Z minus 3, we can easily find its inverse transform. And then we can find the result. So you need to know how to calculate these two constants by this form. And problem B and C are similar to the problem 1, so just skip. And we now look at the problem D here. Okay, so actually now the bound is from 0 to 4. It's not like this the problem 1, the form of problem 1, right? But for this kind of form, actually we can easily write down expression. When it is equal to 2, it is Z over 2. So this one corresponding to the state transform of the impulse signals. And then you can write down its one. So here you see the first one, we can write down the expression of the combination of the step functions. And this one, we can write down the result by the combination of the impulse functions. So these two are the basic signals. Okay, so this problem is very easy. So I think we can calculate it quite easily.